Hello to everyone. My name is Amos, and thanks for giving us this audience. We're here to present our research on radical decarbonization of the electric power sector, how we can model unpredictability and then propose viable transition pathways. I am Amos, and I'll be presenting this paper. My co-authors are displayed on the screen. Our research presentation will follow the following outline as displayed on the screen, from background through to limitations and references. To start with, this is a screenshot I took from the World Economic Forum. It shows that the world we need to act now or never to save our climate. There's another screenshot I took from a different report, how governments are acting too slow to fix the climate problem. There is a quick need to transition from fossil fuel to renewables, and then because there still exists evidence that the greenhouse gas emissions are rising. In our efforts to fix our climate, all sustainable measures are welcome, and we need to fix our climate now, or we will lose it. The climate change, as several researchers report by now, is driven by human actions, and there are several indicators. And electricity consumption is one of them. The electric power sector is one of them. The electric power sector plays a key role in national development. But as at now, for several countries, the electric power system is dominated by fossil fuel. And if you want to fix the climate, then there's a need for a quick transition. There already exists volatility in the electric power system, as this electric power system. And the quick transition from fossil fuel to renewables will even exacerbate the volatility and unpredictability. In order to propose viable pathways, there is the need to quantify the volatility and then the unpredictability, and then add the recorded trends in renewable energy power transition decisions. The radical transition that is required would also, as I mentioned earlier, even further increase the volatility in existing power systems. The top power producing and consuming countries, in terms of electricity, it's arguably they've caused much damage to the environment. So it's projected that it's expected that these top consuming countries would lead the transition. Yeah, and then for every country, the policy culture for every country is different. In the US, it's more of a bureaucratic, where several policies has to go through government debates. But in China, yes, there also exists debates, but relatively, China acts quicker than the US. As at now, there exist two gaps. As I mentioned earlier, there already exists a volatility in existing electric power systems. However, existing research has failed to quantify the yearly volatility for top electric power consuming nations in the world. The existing studies that have already done similar stuff, they've ascribed the unpredictability and the volatility to exogenous variables like price shocks, the global financial crisis, and then COVID-19, among others. The gap number two, there already exists transition pathways to help nations transition to the green system, but all these pathways fail to capture the volatility and the unpredictability. in renewable electric power systems. All right, so here's a screenshot, figures of some environmental and electric power variables, CO2, hydro and geothermal electricity consumption, the HGL, the total electricity consumption, the TED, and then electricity supply from solar and wind, SWL. The black lines are the original values, and then the blue lines are the volatility forms. As depicted in the figures, the black lines are relatively smooth and relatively easy to predict, but the blue lines are highly volatile. All right, so this our work will be focusing on the volatilities. Based on the gaps, the two research questions that needs to be answered are one. To what degree do the existing unpredictability exists for top electric power consumption nations? And then number two, if government choose to factor in policy culture, can the top electricity generation nations transition to green electric power systems earlier than expected? Based on the two questions, our objective is to quantify the unpredictability in 22 top electricity generation countries and to propose, rather than implement, machine learning modules that leverage the observed unpredictability to propose viable transition pathways for China and then the United States. The following is a summary of the methods and materials where data was extracted from the World Development Indicators, WDI, and Enodata, and how we quantified the volatility was based on extended versions by Shorin et al. Forgive me if I'm pronouncing the names inappropriately. Yes, and then we also, the machine models that we use LSTM and then BioLSTM. As machine learning modules, there are pitfalls that raised by Riley in 2019, and we fixed all those pitfalls. For our forecasting, we use the two-stage attention by LSTM, and then the roadmaps for China and the US. We also use the two-stage attention by LSTM. Figure 2 shows the design, the architecture of the two-stage, the bi-LSTM model. Results from figure, we find that on CO2 emissions, every country wants to decrease CO2 emissions, or preferably, every country wants to achieve net zero emissions. Thus, a negative volatility, which shows a decrease in demand in CO2 emissions, year-on-year CO2 emissions in history, is a good sign. From figure 3, here we can see all the countries, all the 22 countries depict evidence of reduction in CO2 in the historical pattern. So if the countries choose to decrease CO2 in the post-2022 the post-2022 decisions, it's feasible and viable because historically there's this evidence. But here are the maximum negative growth for each country. Volatility. We can see that South Korea has the highest unpredictability in terms of CO2 emissions. The United States also reports a negative CO2, negative unpredictability, and then China also negative. However, the negative unpredictability in CO2 emissions is higher for the US than for China. And then there is also electricity consumption. Not only do CO2 need to be decreased, but existing research also shows that In terms of power consumption, there is the need to decrease power consumption and conserve electricity. So negative growth and negative volatility in electric power demand is a good indicator. From figure 4, out of the 22 countries, we find that China, India, and Indonesia do not depict historical evidence that there has ever been a drop in the electricity consumption, thus transitioning to decreasing electric power consumption. China has to tighten the rules and regulations. The other 19 countries depict evidence of negative unpredictability, which is favorable. The country with the highest unpredictability is Sweden. Yes, and then China rather has unfavorable condition in terms of electric power conservation. The U.S., on the other hand, has favorable condition because it records negative electric power consumption, unpredictable electric power consumption. On year generation from hydro and geothermal. Hydro and geothermal are both renewables, so all else equal, if countries could increase the year-on-year supply of electricity from hydro and geothermal, that would be favorable. From figure 5, as displayed on the screen, all the 22 countries has favorable condition. It is also worth mentioning that Thailand it's observed to have the highest unpredictability. Thailand, yes, and then the China and then the U.S., the two top electric power consuming nations, also have favorable conditions. However, the unpredictability, though it's favorable, it's not as high as Thailand, Portugal, and Indonesia. Then, in terms of electricity supply from solar and wind, with solar and wind being renewable, both being renewables, it is feasible that increase in year-on-year supply would also help quicken the transition to green electric power systems. From figure 6, as displayed on the screen, the country with the highest unpredictability is Thailand. We find for solar and wind is Thailand. Yes, and then US and China also do have favorable predictability conditions for solar and wind. However, it is worth mentioning that the unpredictability in China is higher than the United States, and it can be traced to the rate by which supply of electricity from China, supply of electricity from solar and wind in China, it's increasingly surpassing that of the U.S. In figure 7, non-renewables. Every country now aims to substitute fossil fuel with renewables. Thus, a decrease in non-renewable electricity generation is favorable. And the evidence suggests that the country with the highest favorable unpredictability for electricity generation from non-renewables is Norway, followed by Sweden, as depicted in figure 7. The U.S. also has a favorable condition in terms of historical evidence of a decrease in non-renewables, but China, for the data that we used, China does not have the favorable condition for non-renewables. We proceeded to use the machine learning module to propose the machine learning module as we said in our second objective. And we tested for the accuracy, the focus error for the machine learning modules by comparing the traditional LSTM model and then the two-stage attention by LSTM module. From figure 8, it is evident that after testing for the forecast error for 8 variables, the proposed two-stage attention by LSTM module presents significant improvement on the benchmarked conventional LSTM module. Yes. We find that only in one variable, which is hydro and geothermal electricity supply for the world, we find that in only that variable that the conventional LSTM module presents a lesser forecast error than the proposed two-stage attention by LSTM module. We record the least forecast error for the proposed module for world CO2 emissions, and then the highest forecast error for solar and wind electricity supply for Germany. Yeah, so using the least forecast error, we can say proposed two-stage attention by LSTM module records accuracy of close to 99.5%. Yes, if we use Germany's solar and wind supply, then we record at least an accuracy of at least 94%, which is high. So we proceeded to use the two-stage attention by LSTM to make projections and propose transition pathways. So here is the power projections for China. From figure 9, as displayed on the screen, it is predicted that by 2030, electricity consumption in China would reach over 13,000 terawatts by 2030. However, the transition pathways, as can be seen from here in 2025, means that all the 6 proposed pathways show that if China should keep the policy culture, then there's high probability that they can achieve 100% renewable electric power systems as early as 2025. Thus, China can achieve the green electric power system earlier than predicted. It is worth mentioning that for all the pathways proposed, supply from solar and wind significantly contributes higher values than electricity supply from hydro and geothermal. This is depicted on the table on your screen. On the US, yes, it's projected that there will be an increase in electric power demand for the US. That by 2030, it could reach 7,851 terawatts by 2030. Out of also the 6 transition pathways proposed, only 2. We find that there's only 2 of the pathways that shows that the US can achieve 100% by 2030, which is earlier than predicted. That is, if they use the unpredictability and then the volatility proposed pathways. Yes, so those 2 pathways are the green line and then the yellow line. The gray and the blue also show that the US could increase electricity supply from renewables to a greater proportion out of the total demand by 2030. However, the gray and the blue, the results show that the US, following their policy culture, cannot achieve 100% of the power systems by 2030. Out of the 6 pathways, there is 2 that support the evidence that the US can achieve 100% electric car systems by 2030. Just as in China, we must mention that same for the US, solar and wind contribute significantly to the proposed pathways than hydro and geothermal. So from the results, our contributions are that we've been able to quantify the volatility and unpredictability for 22 top electric power nations in the world. And we've also been able to propose high accuracy, attention-based machine learning module for forecasting. We've been able to use the model to forecast for China and the US's electric power consumption up to 2030. And then we've been able to show that for China, the country can achieve 100% renewable electric power systems between 2025 and 2030. For the US, because there is only 2 out of the 6 proposed pathways, proposed volatility-driven pathways, the US can also achieve 1% electric power systems by 2030, but the probability is relatively low relative to China. Our recommendations, we recommend that researchers can inculcate the observed volatility and unpredictability in modeling environment, economy, and electric power systems. Researchers can also model the expected unpredictability. Here we mean future unpredictability by learning from the historical unpredictability and then adding the expected unpredictability as a key variable in proposing high accuracy data-driven forecasting modules. Policymakers, on the other hand, are encouraged to cooperate and coordinate with researchers because all else equal, researchers are able to they have upper hand in quantifying the unpredictability and incorporating them in proposing pathways, and policymakers are the people that shape policy. So cooperation between the two will be instrumental. Lastly, it's also recommended that leaders and decision makers they should encourage private sector investment because transition to the renewable electric power system, such a quick transition will be made possible should private investors, individuals, and organizations increase their contribution in terms of transition to the renewable electric power systems. Despite our results and contributions, there are a few limitations. First off, there are over 200 countries on the planet, but our study focuses on only the top 22 electric power consuming nations in the world. And these 22 countries were selected based on data availability. Yes, so for other researchers could research the other countries and then extend the data availability too. Number two, we've been able to quantify the volatility in several variables, several environmental, electric power, economy variables. However, this study does not investigate the reasons that explain the year-on-year volatilities. Historical evidence suggests that shocks, as I mentioned in the background, like COVID-19, the global financial crisis, but these are studies did not provide answers for all the year-on-year unpredictabilities for each of the 22 countries. Other researchers could help fill such gap. We also use 22 countries to quantify their volatilities. However, in terms of prediction and transition pathways, this study selects China and the US. The US and China were selected based on variations in the policy culture, as mentioned earlier. The US, it's more of a red tape. It uses red tapes, and then China, it's more of act now with the considered effort of the government. Yeah, so that leaves 20 extra countries that can be investigated by other researchers. And then lastly, this study does not also provide the investment cost, the total dollar value of the investment required to achieve such radical transition. Future researchers can also explore such gap. Here a few references that support our research. As a guideline, O, it's the fact that we pick from online. R is from a report, and then J is from a journal. Thank you for listening to our presentation, and your comments, contributions, and questions should be directed to Amos, myself, the presenter, and my email address is displayed on the screen. Thank you.